Alrighty, it's the last day of Code. Ah, it's been a fun one this year. um, so tonight's problem is usually a short one, right? Probably, what, half an hour at most if I'm super brain farting. And it's just a one-part problem. And part two I'll have because I have all of the previous stars. What I never got around to was all the references to past days. Let's look at one. So I started one. What's this? 2016 day two. Let's go for it. I did also start on day nine, but let's do a day two problem. We haven't done this, right? Okay. 2016 two. What do we have? Easter Bunny headquarters. There's a security document. Bathroom code's no longer written down. Memorize and follow the procedure below. Okay. Um, each button to be pressed can be found by starting on the previous button and moving to adjacent buttons. UDLR, okay. Each line of instructions corresponds to one button. So these are instructions. So we start somewhere up, left, left. I guess we start at 9. So 4 is the first one we hit. Okay. Where does it start? We start at 5. Move up and then left to 1. And you can't move left again, so you stay on 1. All right. So instead of hitting the back border, you just stay in place. Okay. So we're going to import our point, direction, and area. And input is a bunch of lines, list of directions. Okay. Let's see. Let's turn a line into direction. Def directions from a line. Yeah, list of direction. And I think we can just line.map dirt from. No. We want a parse. Do we have a parse? I'm not sure what we have. Interesting. We don't have, I mean, they're north, south, east, west anyway. Okay. So line map, and we'll just do a case. So case, we have a character up, dot north, case down. Let's turn Copilot on here. Left and right. Okay. And we have a key. How does it know we have a keypad? Does it just know what admin code 2016 day 2 is? Is it trained on that? That'd be all right. Well, anyway, well, keypad. It doesn't work that way, buddy. So you want a map from, do we want to point to character? Yeah, we want to be able to translate our points to characters. Yeah, assuming 5 starts at 0, 0, then 1 is -1, and then 1. No, that's not quite right. So we're just going to parse the string. So val raw equals exactly that. We're going to do an area around that. So raw dot to vector area the point. Add no strip margin. We'll just turn this into a vector here. Okay, so area, and we get the points iterator. Great. P to raw P as digit. Turn that character into digit. And then that whole thing becomes map. Okay. And I guess movements. So the movement rule is special here, so we should just write that down and code it. F move point in a direction, and then we have a new point. Okay, so p dot move in that direction, and if it's in bounds, I think we want our area. So let's do this. We'll call this the raw keypad. Just call it raw. Val area equals area raw, and then keypad will be defined here. Okay. And let's see. Match next point. If keypad contains the next point, we give that next point. Sure, otherwise we stay in place. Exactly. And to get a code, we just do that translation for each line. So lines or input map directions. And then I guess we'll map that as well. Input map line. Honestly, this directions here should just be a map on the input. So we'll make that val directions equals that input map. There we go. So directions map line, and we have a starting state. because at the end of each of these, we have a continuing. I have continuing state. This isn't just a map. I guess this is a fold left to get a code. So we'll fold left, fold left. And now we have, well, hold on. We need a starting state. So we start at 5. Point, what is the point of, I guess we take, we'll just define it. Val start equals 1, 1, right? We get assert start is, or keypad 5. So keypad let us start is equal to 5. Okay, so we have our current position, and then we have directions. Hey, Michael PC Gamer, welcome. It is the last day. You didn't get part 2 yesterday? I mean, I don't blame you. That was a lot of work. Why is 45 your goal? Hellhound, welcome. Yeah, I'm excited. I'm excited. Keypad start. That's fine, sure. So we're gonna do what here? Let's turn Copilot off. So we start at that point, and we can just fold left. Where's that fold left? Start with that point, and then p.move, or I don't know, call the move function with that p in that direction. I think we just pass in that move, and that's fine. So that's the final position. And then we get the keypad of that. So there is a state, but there's also the string, the code that we're building. So we're going to start with an empty string. So position, code. This is the digit that we're placing, and code plus that digit, and then a new position. So val new position is there. And we have the new position and the next code. Directions. Wait. Directions isn't a list of dir. This is a list of dir. We to list this. Well, should be a vector of string. Oh, the individual lines. I don't know, split at. One minute. Where's my alarm? Oh boy. Okay. Let's comment this out. We're done. 40 seconds left. Feels more official than 44. Fair enough. I guess timer did go off. I appreciate it. Okay. Our day 25 worksheet. Code Chronicle. You have 5-pin tumbler locks. You send over schematics of every lock and every key on the floor you're on. That's the puzzle input. Okay. So this must represent the pins. Hey, Merry Christmas. It is Christmas. Mhm. So schematics of every lock and every key. The schematics are in a cryptic file format, but they do contain manufacturer information. Virtual 5-pin tumbler product. Way more secure than yada yada. You can rule out some of the key lock combinations. A bit intoxicated. Hey, that's fair. I've had my night. The virtual system is complicated, but part of it is really is a crude simulation of a 5-pin tumbler lock. Okay. So these are example schematics. The lock schematics that have the top row filled and the bottom row empty. The keys, top row empty. Okay, so these are keys. This is a lock. And I guess we see if they fit. Each is actually a set of columns. Okay, yeah, of course. Either downward from the top for locks, upward from the bottom for keys. Okay. Um, you can convert the pins and schematics to a list of heights, one per column. Uh, so this, say, has height 05343. The lock. So this is a 0. Or key, the matching key, I guess. 50213. Okay, yeah, go on. It seems like they should fit together. This cannot be the key for the lock. In the rightmost column, the lock's pin overlaps to the key. Oh, I see. Yeah. So anyway, you can narrow down the keys you need to try by just testing each key with each lock. How many locks? I don't know how many locks we have. Oh, excuse me. Okay, so converting all 3 keys to heights. Then you can try every key with every lock. Those overlap in the last column. And what are we looking? So how many unique lock key pairs fit together without overlapping in any column? Okay, I mean, we can brute force this. Excuse me, thank you. Okay, so schematics, I'm gonna do this. So lines is an iterator. Val lines equals that. Could do a list buffer. We'll call this schematics. And this is a list of, we'll just do the raw grids. So vector string. Or something like that, we'll see. So collection.mutable.map or in a list buffer. And we'll do lines take while not empty. And this whole thing will put in a big loop. while lines has next. I'm having to remember how to write a while loop mutation. Take while not empty. I guess this is a schematic. And then I guess we're gonna two vector that. So vector string. So schematic dot two vector, and we add that to our list buffer. And then we do lb.toList, and that's it. So we have all our schematics. And then we'll get all of the locks and keys. Val locks equals schematics filter. Um, so what the first locks are facing down. So this is lock. So the first one is all full. So we could just do dot head that for all. It's just that character. And val keys. Similar thing, except it's the last. I suppose we could then convert those. So for the locks, to convert this has to be 0. So we just do the count in the columns -1, right? So filter dot map. So we're just gonna transpose dot map count of the hashes -1. Okay. And then similar thing for the keys. It will also just be the count, right? Wait, hold on. Here it was a count -1. So this is 0. Here, it is still a count. Is it +1 though? So this is 5, 0. I mean, it's still -1. Same thing. Okay. And then our answer is going to be for key and keys. We do locks.count. How many unique lock key pairs fit together without overlapping in any column? Okay, and I hope there are no duplicates. So we'll just do keys.map locks.count. So given the L and the K. What's this? VWoov. Welcome, welcome. Are you waiting me because you already finished? Did you call it day already? Let's see, I'm gonna change this to so locks.count L such that how do we do this? L.zip K map with addition And for all, it's less than 5. Yeah, not for all, less than equal to 5. And then we sum all of those. Whoops. 2,900. Hey, there we go. Continue part 2. And we just click deliver to Chronicle. Hey, done. Oh, you just finished too. All right. Hey, hey, we're done. We're done. That was an easy one. It's supposed to be easy. So 653 overall. What are your ranks? It has been. It's been so fun. I was thinking it'd be nice to decompress a little and do a retrospective on all the problems we did this year. Like I want to know what everyone's favorites are. 553. Okay, we've said done basically at the same time, I feel like. And that's a whole 100 between us. That's crazy. Let's see who's finishing up. There's a few of us. So arrow bounce, 8th overall. Oh, I'm not going to be 8th anymore. I was 8th for most of the season. The last few days kind of slowed me down. I haven't seen arrow bounce in a while. Oh, 566. 29 seconds. Jesus. Really? Is that possible? Okay, so you parse whatever you get the counts. No, you can't even read it in 29 seconds. I mean, you take a wild guess at what the problem is, I guess. What keys fit what locks? It is suspicious. Very sus. That smells like an LLM. Because, I mean, Alexander Hop, we know, is super fast. I guess it's a slow day for them. The next one is 3 whole minutes later. So, Ken Harned. I've not seen that name before, even. Wait, is this global? I have a global ordering. I see, that's why. You just watched Larry NY solve both parts in like 3 minutes. Yeah, I mean, I think faster is possible. Um, I mean, it's really just a one part, right? So we have we have people here that solved in 3 minutes. See, 3 minutes is very believable. 30 seconds sounds kind of sus to me. Okay. Um, let's read. Let's enjoy this a bit. Wrap it up. We try hand in the Chronicle. Oh, the Chronicle is for us. It's a record of all the places you've been and people you've helped over the last decade. Thank you for everything. Hmm. Also, there's a new design in the shop if you're interested. If you don't see it, give it a few minutes. Interesting. Oh, a 10-year tumbler and a 10-year shirt. Honestly, I don't go for merch much, but after surviving, if I were part of the 500 Star Club and I just survived this 10th year, I feel like I'd be pretty tempted to grab one. Anthony writes code is 39 today. I mean, I suppose you shouldn't be streaming if you're that fast, right? Or at least, you should stream with a delay. Anthony writes code was here once before. He did stop by with a raid. That was a pretty fun one. You finished every puzzle in Avenico 2024. Get in touch, contact, and now we've highlighted Easter eggs in each puzzle. Yeah, I never search for the Easter eggs. I always just wait to look at them after the fact. Emperor Alex just got part one. Great. Is it just me or does it seem like there aren't as many people streaming Advent of Code this year? Like when I logged on, yeah, it's a very small list. Maybe my filter is too aggressive when I search for them. Okay, I've got every problem up in here. Well, these are all the references of the problems, but just go back to look at them. Um, this is your first year? Oh, awesome. Yeah. Good on you to finish the whole thing your first year. So you still have 9 years worth of problems to go back through. Last year was Bonanza. Wait, what do you mean? How exactly did you discover? Show the front page again. Oh, okay. Yeah, let's take a look. Right, it's moving now. I still don't understand all the references here. Um, like I think this is 2017. The hat is 2016, the second year. Or is it the first year? The Christmas tree, I think, might be the first year. Um, where's the jungle? This might be the jungle. I'm gonna have to look at a Reddit analysis of this. You got a sleigh going. There were about 40 people streaming AOC last year. Yeah, it felt like that, didn't it? A whole year to solve past 9 years. So you can repeat this month 9 more times. I don't know if there are references in the animation. I think it's just in the map itself. Like this is all 9 of the previous years. But I would have to look. So to understand them, I'd have to look at the previous year's maps. And the problem is I don't have them all completed. So Let's try this. Well, 2024. 23 was the island hopping. I think that's here. Yeah, that's definitely this one here. You can see the same bit with the two stars connected. 2022 was the jungle. Um, it had lava flows. Oh, volcano here. It's in the bottom left. Okay. 2021. Wait, did I skip one? Nope. 2021 was the deep, the ocean. Is that this? As you can see the trench. Oh, there's three of those islands, not just that one. Wait, I don't see the other references right off the bat. Oh, right, there's this one here. There's that island. And where's the other one? I don't see lava flows, and whatever this is, I'm not sure. Green Island is the one. Volcano is the left part of the O. Wait, I think this volcano might be a different year though. Oh wait, volcano is the left part of the O. Ah, yes. Okay, okay. Here's the volcano island. So we have one, two, three. Three of the islands mentioned. Nice. Good eye. Good eye. I see it. Um, and then this volcano is part of the jungle. I don't know if there's another jungle reference here. Oh, nope. This here. This is the rope bridge. Do you remember the rope bridge problem? And I feel like every time the monkeys showed up, it ended up becoming a hard problem. I'm blocking this with my head, aren't I? You killed part two of the rope bridge. I'm sure that felt good. Okay. The trench. I've never been able to see the trench in here. I think this Nessie is a reference to a different problem. I think this just might be the trench here. That's as close as I'm getting. Well, okay, there are these lights. Oh, here, it's here. Oh, are those lanternfish? No, no, no. It's just like you had lights going all the way down. Okay, so here is the deep. Oh, and you can see the top of the ocean. All right. This I can't exactly remember. This is island hopping. Oh no. We just have to wait a sec whenever it does that. All right. Um, wait, what happened to it? Okay. Um, well, there's the Nessie here. So the Loch Ness Monster referenced right here. Okay. 2019. I guess it's a solar theme. See, now we're getting into stuff I don't really know all that well. All I know is that this year had an int code machine, and I went straight for those problems. And the hat from 2018, the Santa hat, bottom left. Circuit board 2017, that's here. City blocks for 2016. This was the Easter Bunny year, which I haven't done yet. Um, I can't figure it out. But 2015 should just be a tree, right? So that's this. Okay, those are the references. Um, yeah, I do still want to do a tour of everything we've done this year. Maybe City Blocks is an animated thing on line 9. Oh, I guess, yeah, so that's a subway going through a city. I see it. I see it. Nice. Um, let's see. I want to make a new file here. Just recap. Make a markdown file. Okay. So day 1. What do we say about each of these? We discussed the difficulty. So day 1, super easy, right? I don't think there's anything too special about that. What are you seeing in the stats for this year? Let's see, 2024. Okay, basically a one-liner, right? Sorted zip. Okay, sort them both, zip, get all the deltas, absolute value, and then get all the counts, and how many times does one appear in the other? Right, so one-liner, not all that interesting. Let's rank them for like difficulty, um, and fun. I have no other notes about that one, but I don't know, it's a start. We always start easy. You start an hour late, day 11. I'm glad I haven't done that. There have been a few nights where I was taking a nap before coming on to stream, and I could have easily just kept on sleeping. I don't know if you could tell when I just woke up, but there were a few of those nights. Um, add stats. Where are the sudden dips? It's interesting to me that 16 is a sudden dip. I would have expected 17 to be more of a dip. I mean, I guess it is more of a dip. Because 16 wasn't that hard, was it? It was just a grid search. 21. 21 definitely has a dip. It's interesting that fewer people have solved 24, because I think 21 was harder than 24. Yeah, an alarm on your phone for adding a code. Let's see. Day 2's, we count safe dampened. Um, what was this? Let's see. Um, the levels are all increasing or decreasing by 1 or 2. Oh, so these are each rows. So we get the deltas, and right, we just check pairwise zip if they're all match that criteria. And for safe dampened, we additionally So I mean, this one was slightly harder. I'd still say it's like not as interesting. Or I don't have it like anything particular to say about it. I mean, I did like that the twist. Um, oh wait, ah, this twist. Um, this twist had me wasting some time, didn't it? Um, because if you try to do it in one pass, it's harder. So there's like a potentially interesting challenge there. Um, so what? There's a say potentially interesting one pass challenge. Okay. 8 part 2, 17 part 2, 21 part 1, and 24 part 2 were the most challenging ones. You've got to learn A star. 16 was Dijkstra's. Fair enough. That is a stumbling block if you aren't used to it. But yeah, totally do A star. I mean, it's just gonna be Dijkstra with a little modification for the heuristic. It's basically Dijkstra with a guess. So I think you've totally got that. 20 and 22 are the most challenging. I didn't think 20 was bad. Oh, the cheating. Oh, yeah, actually 20 is the one that I didn't finish. I went to bed after part 1. I didn't even try part 2 that night. And I think the next night I logged in a little bit early to do it. And I didn't get it by midnight because I missed one line here. Um, okay, let's move along here. So 20, day 3. Computers are having issues. What was this? Day 03, 2024. Oh, regex. I'm just gonna write like actual notes on here. So for this one, I had a fear of regex, right? Like it was tricky in that looks like a parsing problem. And when it's a parsing problem, you don't want to do a regex, but isn't. It's just search, just use regex. Yeah, I did a hand-rolled parser and it took longer to write that, but I did like how this cleaned up as a regex. The cheating one seemed hard, but then it was just running Dijkstra from. I didn't end up running Dijkstra myself. Well, I mean, I started off with Dijkstra, but since there were so many ways to cheat, I got overwhelmed with states for part 2. Okay, so day 3, that was that. Day 4, oh, the Xmas search. This one was fun, I thought. Okay, I mean, it did take a lot of copy paste, or like just not generalized code. Um, yeah, super verbose. Day 4. Well, I can make that one more concise. And what do you have to say about it? I mean, I think like the difficulty's going up. I think it's interesting in that there's still stuff to do about it. So is this a 2 of 5? Maybe this is starting to get to 3 of 5. We'll say 2 of 5 difficulty. Um, 3 of 5 interesting. Okay. You hard code explicit searches for 4 possibilities on. Yeah, I saw. I think that's a good way to do it. Like, this is sort of in a way a bunch of hard coding here. I should just have this kind of stuff be part of a library, like word search. Add word search to library. But I did like that there are a lot of different ways you could express the second one. I mean, so for mine, I basically said, top left and bottom right. Do those match? Right? The things surrounding the A, are they you know, are they M and S or S and M? Okay. Day 5. This is the print queue, the polymers. Um, this one, this one is too straightforward. Um, what exactly was the issue here? No, this is the wrong day 5. Hold up. Day 5, 2024. Okay, before, after, we have a bunch of dependencies. You didn't make cheats part of the search. Okay, let's look at day 16 already. I want to join this conversation. Okay, so you didn't make the cheats part of the search. You got the shortest path from the start to every node, and the shortest part from the node end to every node. Okay, no, that's a good way to. That sounds smart. Then go over each path tile. Cheat offsets comparing. Yeah, so you look at what it goes to. I mean, but that still doesn't really need Dijkstra, right? Like, you could Dijkstra the shortest path, but there's only one path. So you could just basically make the path from start to end. Wait. Oh, wait, I'm thinking about a different problem. Right, 26. You're right, you're right. Day 16 was totally a Dijkstra. In fact, is this the cheating one? No, no, no. We're talking about day 20. Jeez, I'm on the wrong page. Yeah, I mean, so for the cheating, there is only one path. So you don't even need to Dijkstra. Um, so I did it with the one path, and I basically looked at one point and another point, and I was like, well, these two, right? So I just take the cost of this getting to the end, subtract 2, and add the cost of this to the start. So similar idea, like over a shortcut, and then just do that over a larger area for part 2. I mean, I did the same thing. I also started with a Dijkstra. I assumed it was a maze. And then because I started with a Dijkstra, I started turning all of the cheating states into states in my Dijkstra because I was like, okay, there has to be some sort of branching. So I turned all of these into branches, but the problem is now all of these are branches. Let me pull up my day 20. Day 20. Nope. Day 20.worksheet 2024. Here we go. So after I took out the Dijkstra and stuff, it ended up being pretty short. Just get a list of paths for the point by looking ahead, left, or right. And then to cheat in part one, this doesn't matter so much because it generalized. This is what I described. But to cheat in part two, we look at time saved by subtracting um, the usual time from the usual time to, and then getting the distance from one to the other. And if the time saved fit and the distance from one to another was within the cheat range, then it was cheatable. So pretty simple in concept once you get this idea. Um, yeah, I mean, I slept and I think I just came back with this idea the next day and it didn't take long to write it. Going back in time, any stars I didn't get. Oh, just ones from past years. So 2015 through 2020, I don't have full stars for. You wonder if the linear path makes much of a difference in runtime? I don't think it should too much because you could still just wait, you could still Dijkstra and jump from one to another path along the Dijkstra based on its like min cost. Mm, yeah, I'm not sure it would make too much of a difference. Okay, so what, day 20? Not a Dijkstra. Um, easy once you get it. I had too much fun making a state machine. I was over engineering a little bit that night when I started. Um, but yeah, let's look at day 16. So the reindeer maze. Yes. This one, having the way you're facing be part of the state made part two annoying. No, there is state in your functional. It's immutable state, right? I don't mutate it, and it's still functional programming. Uh, the Dijkstra has mutable state. Yeah, so for part two here, I was curious if anyone did kind of like a search from the start to the end and the end to the start to see if a path was basically, you know, sum the min cost of either of those two. The problem was that like a state is not just your position, so you can't just do the path at that position. You have to like have a direction you're facing. Then you have to like, reverse all the faces or something like that. So I ended up just having like a breadcrumb and searching backwards. But that made it even more annoying that like the pass back now also needed the time as part of its state. And our state wasn't just a position and direction. Um, but I appreciate that it's not just like a 2D Dijkstra. Guhani, thank you for the follow. Okay. What was day 5? Do you remember this problem? Dependencies and then correct order. Okay, so this was a topo sort. And I don't think I like explicitly did a topo sort. Um, Oh, it so happened though, uh, that so it is a partial ordering, but in this case, um, not partial in given examples. So that's the insight that made this work. So you could just use a normal sort. So the fact that it needed a little bit of that insight made it a little bit fun. Yeah, you felt clever. Just call the standard library sort function and give a comparison function. Yeah, exactly. It was fun to get that insight. I did the same thing. So I mean, here, this is my sort with dependencies. A dot contains B, right? Is A a dependency of B? And I could probably do this in a more concise way. Oh, someone did this with just like a set of pairs of points. So instead of like a map from a point to a list of points, then you just check that set contains. So you could say edges. So this is oh, about edges equals of that type. Then for this sort with, you could just be like edges.contains. And that's clever. So I like that. Okay. Yeah, didn't have to filter any of the relevant rules. So there's a nice chance to get a speed up. So no need to learn topo sort. I'm rusty and I don't think I could have done topo sort on the spot. Uh Day 6. Um so guards walking, oh right, simulating the guard moving around and obstructions. Okay, I remember. Okay, I had to do an is loop line path. I think I made this harder than it needed to be. Did anyone feel clever on this one? Basically, my way of making this work was just to go like laser all the way to the next in sight. So I'm not simulating every single step. But it took me a while to do that. Sure is vertical. Yeah, this one had me being messy. It feels similar to banana trades. Used a map with 4 price changes as key. Oh yeah, totally. I did that too. Or no, wait, did I? Yes, I did do that. Um, let's see. Optimization and I don't know. I want to make this concise while optimized because I think it can be a lot more concise than this. If anyone had a really concise solution, I'd be interested. Day 7, bridge repair. What was this input? Oh, all the operators. We just basically filled in operators. I think I basically just got this one on the first try. Yeah, I just do a recursive search of solvable, but my little insight was to reverse the operations um, in my recursion and basically keep the equation balanced. So the left hand side gets divided, and then the right hand side gets its first bit chopped off. And for part two, it was just the same thing, but you add this string manipulation. I need to make that more concise. But this one felt very easy to me. Day 7, you missed the order of operations, always left to right. Yeah. I was bracing for part two to care about order of operations. I feel like I had a fast time this day, but who knows? Okay, day 8. That would have been a nice delta for you. Day 8, resonant collinearity. What is this? Oh, this one, I really enjoyed this one actually. Okay, so wait, day 7, straightforward, recursion, keeping balanced. That was easy. Day 8 was fun to write. Use a bitmap distorted direction bits for day 6. It was day 6. Oh, okay. Nice. I mean, I used a hash SAS state that also included the direction of the position. Um, yeah, that's a good way to do it. Day 8. Oh, day 8, I think I was top 1,000 on both parts. Um, I felt like I just chugged through this one. Yeah, and I think for me, this is easy because I already had addition and subtraction for points. So I could just compute the delta, and I could just add the delta. So add the delta, subtract the delta, and I found those two other antennas. And this is basically a one-liner to get all the antinodes. And for part 2, we have a delta, but we also have an epsilon because they might have I don't know, we just want everything that's like an integer value, right? But again, this is easy because I could iterate, and just add my epsilon. I already had an add function. So this felt pretty fast for me to write. Day A was look at the pictures, don't think about the words. Honestly, I should have. That's smart. I mean, I know sometimes like you could just understand what the problem is by looking at what the input is and then like scanning over. But when I try that, I get burned. I think I got burned earlier this year trying to like speed read a problem and misunderstanding it. Your 2 rank was better. So it's good to get a good delta. Let me see what I had. So 2024 self. Um, oh, my delta wasn't as good for day 8. It felt like I was fast, but I didn't. I mean, I still was top 1,000. So this was a day when I was smooth. Okay, where were we for day 9? Uh, intervals. Occupied intervals, free intervals. This was a lot of code. Oh, I want to refactor this. There's a big refactor possibility here. We could just get all intervals. I kind of tied my hands by trying to do one or the other. Um, Endless part one, checksum. Data is fun. You got your top 1K for part two. Great, great. I did think Day 9 was a fun one. Day 8 is still one of my favorites. Um, I feel like I'd like to do a tier list of my favorites. Day 8 would be a second tier. Maybe third, depending on how favorite my real favorites are. But interestingly, Day 9, I did also feel like part 2 was easier. Did anyone else feel like part 2 was easier? Because part 2, like you're just moving the whole chunks. Um, and that was just, I don't know, easier to manage because I already had like a map of chunks to their locations. He just flat expanded blocks. Hmm. I mean, for part 1, that makes more sense. You could basically sort of like zip these two together and fill in one from the other. And it's just pretty linear. But yeah, for part 1, you really don't care about intervals. And we should be, instead of writing notes, we should be making this a tier list. Um, let's calibrate. So day 9, uh, let's say day 9 is a B. Let's say 9 and 8 are both in B. Nothing is an F tier yet because we don't, nothing made me hate myself so far. But I can imagine a past tier, me wanting to say something as an F tier. You did graph to understand what they're talking about, but solved in code. Wait, graph is for day 9? I'm not sure what that would get you. Dot couldn't do it. B goes in the day 9 tier. That's a bit backwards, isn't it? Um, Eric was in here that night and said the input was designed to trip up graph viz. Really? Oh, I missed that. I'm gonna write a note. Input meant to trip up graph viz. Are we really talking about day 9 with graph viz? That would never have occurred to me to use graph viz here. Huh. I mean, I still don't get it, to be honest, but I don't know. I'm missing something. Oh, day 23. Yes, yes. Okay, that makes so much more sense. Um, right, for the LAN party. Trip up graph is. Right. I remember someone dropped, well, yes, you did, 10x programmer. You dropped your graph is, and it was like you said it was like 24 megabytes. And I've never used GraphViz offline. I've always used in a website. And it probably crashed in the website with that many. Yeah. So that's day 23. Okay. Day 10. What was this? Trailheads? Oh my god. This was the one I saw backwards. Day 10, super easy, reading comprehension. I don't know how so I implemented part two, right? And I spent the longest time trying to debug that. I really did. But I wasn't the only one. Yeah, yeah, I remember a few of you did that too. It just took me longer to catch on. I and misunderstood. Uh, Rick. Okay, you know what? I'm allowed to hate that one. That would be my F tier problem. We can have one F tier problem, and I have a grudge against that one. Uh, okay, day 11. The pebbles. Oh yeah. This is fun. I can't remember what my solution was like. This feels like it's too long. But match each of those cases. I probably don't need to like fully simulate it. But yeah, just memo. This is one where it's like very obvious from the start. You got to memo it. I hope it was obvious to me though. I don't know if it wasn't, then this probably took me a bit longer. Was it day 19? It took me so long to finally do memo. Um, I would say this one's kind of boring. We'll put that in 11 and C. Each stone doesn't interact with neighboring stones. Yeah. I feel like that insight is basically kind of free. Oh, wait, did I start? Hmm. No, did I do my memo wrong at first? I think I did my memo wrong because I was worried about the times. Yeah. So I wasn't thinking about how like horizontally within the same time frame there'd be a lot of memo. I was thinking kind of vertically, how like you'll see a lot of the same stones. It took me way too long. Um, okay. I'm not allowed to call that a C tier if it tripped me up like that. But you know, it wasn't as fun as 8 and 9, was it? Maybe it was. Jeez. Yeah, I miss the insight that you would get a lot of the same numbers within the same time frame or time step. It messed you up too. I mean, we've done memos so many times in the past. I mean, like, I don't know. When the lanternfish problem came out, I got that one right away. In fact, I memoized it in 3 different ways. Um, I used a lazy list. I used like plain old recursion and some other way I can't remember. Okay, day 12. Oh, the farms. Um, This was fun. What was it? Like flood fills and then perimeter. Oh, okay. Part two, though, getting the number of sides, that needed the corner insight. Um, this challenged me for a bit. I definitely needed to draw. Yeah, part two. So I needed the insight, just count corners instead of sides because my sides was so buggy. Um, and then when I counted the sides by walking around, it didn't handle holes. And I strayed away from the corners because I felt like, oh, you have to search the whole thing. But I mean, once I started implementing corners, it was easy. Um, like this is so much easier to implement than counting the sides. Yeah, I never fixed my sides implementation. I mean, I think I did finally get to work properly, at least for the outer sides, but then the inner sides you still have to do. And I tried some dumb shortcut that didn't work. I have a habit of trying shortcuts that don't work. Um, I'll make that an A tier. We already know what our S tier ones are going to be, right? They're 14 and 17 and 24. We'll see. I know what my favorites are. Um, oh, the machines here. Oh, I remember spending a long time because I had this at 1 million instead of this number. I had to, yeah, I spent a lot of time debugging that, and I had a minus and plus flipped. And it reminded me that I'm not really comfortable solving the, just using the, what do you call it when you do it with matrices? So there's a Gaussian elimination, but just for a system of two equations, I just need to get more comfortable with that. Day 13. I need to get more comfortable with linear algebra. Okay, I mean, I like that it pushed me to think about that. And I like that it was kind of mathy. Um, I'm gonna say 13 is part of my A tier. You solved it with a computer algebra system? Oh, cool. Yeah, I downloaded one once and started messing around with it for like a group theory thing I was doing. I just wanted to like multiply some permutations. Oh, for day 12, you saw an interesting solution where someone stored fences as points and direction vectors and making them go clockwise to be able to tell them apart. Yeah, that would be smart. Be able to tell size apart. Right, but you need to do like some sort of translation on it. Let's see this link. Oh, right. Oh, is this a screenshot of the CAS or the computer algebra system? Nice, nice. Maybe I should just have it as a tool in my bucket. Like I've had a feeling that with admin code, I just want to do everything from scratch. And over time, I've been losing that feeling. Like last year, I used GraphViz a bit, and then 2 years ago, was it? Or no, last year I also started making a library. WX Machina. Nice. I like I like the name. I haven't heard of that one. Okay, day 14. We had a robot in a position. What was this robot doing? So D13 was a claw contraption. This 1 million. So this miscopy combined with just having a flipped plus minus sign. Man, you gotta be alert for Avena code. Okay, the robots. Oh, the robots. Yes, the robots. Okay, this is S tier. This is so fun. You ended up writing the 2x2 matrix inversion by hand. Yeah, that's fair. But I need to be more comfortable with just using the matrices, the inversion matrix. Yeah. This is the first AOC you did completely. So now you feel like you need to make a utils package for next year. Definitely. What would be in yours? I mean, so mine mostly contains it's mostly like point area, like all the grid stuff. I think that's certainly helpful. I think I would add to mine. Maybe I would just implement a generic Dijkstra where I pass in what I'm using for my state and my state transition. I mean, I could probably write a generic A star as well. I think that'd be a fun exercise. That way I just pass in functions to my search and then I can just do it. Yeah, the tree. The tree was so fun. Uh, I still I still want to explore day 14 a bit more. Um, and I don't understand. Like 7687 is the answer, right? But why doesn't it look like the answer when I search it here? I was like recreating my first approach to it, and I don't know. So I do want to like explore this and explore all the various ways to solve it. But it's super fun because there's so many different ways to solve it. And that you didn't even know what you're looking for. You had to figure out what you're looking for. So it required exploration. You're going to separate parsing from the computing the answer. Yeah, having a parsing library, that's a great idea, actually. I should I should consider that. Having a parsing library would be very helpful. It wouldn't be AOC if I didn't read the problem and just read as you open Wikipedia for A star. You know, it's really not that bad. I mean, if you look at my extra here for day 16, oh, okay, this isn't the best example because it's has a lot of other stuff going on, but it has a priority queue, right? And you order by min cost in the priority queue. Um, but here you just order by like a second thing, and then the second thing is just going to be your heuristic, which is usually just going to be like Manhattan distance to the end. So like p dot dist to end, and that's basically it. That gets you A star. Or like you might have a better heuristic than that, but the point is that you also consider some estimate where that heuristic is never going to overestimate, but it's going to be like a lower bound on the cost. So as long as you know what fits the criteria for heuristic, then A star is a very easy extension on Dijkstra. Yeah, the Christmas tree, definitely S tier, 14 for sure. Yeah, boost, and your skeleton has examples of using it for tokenizing and regex. Wait, what's boost? Should I be using that for my input too? This is so fun. It's so fun to like scroll through and be like, oh my god, there it is. C++ library for anything and everything. I see. I see. Um, I mean, as I've solved these problems, like there are plenty of Scala libraries that exist. I'll do things I kind of start doing by hand. One thing that never happened this year, we never had a parsing problem, right? We never had a proper parsing problem. And Scala has a lot of a good variety like parser combinator libraries. I would like to make my own parser combinator library so I could justify using it for Avena code. Um, but I felt like in past years when we had a parsing problem, I did pretty well. But this year there wasn't any. And by parsing, I mean like parsing expressions or a language. That's more than just assembly lines, you know? So day 15, warehouse woes. What was this? Boxes and walls. Oh, yeah. I was so buggy on this for the longest time. Okay, so part one, I think I breezed through. That was pretty easy. Part two, I had namespace collisions. And then this bit right here, when you're moving something too wide into the, so my walls were also too wide instead of just having two walls, which I should have done. So I was only searching two ahead because I was like, okay, I'm too wide, but I had to search three ahead actually because the other thing is also too wide. So it took me a while to realize what was going on there. And I don't know why my printing of the state, printing of the map was buggy that night, but that made it hard for me to debug because I just didn't have printing. So I think I can tighten up my act for this one for sure. But day 15, otherwise, I would say this is one of the funner ones. I really liked the puzzle itself. I like this, simulation. Yeah, I felt super confident going into part two, and then just was so buggy. I think I'd have had a much easier time if I didn't make the walls too wide as well. Like they should just doubled the walls and place another wall next to it. You were a little bit scared of part two. I think it was good to be scared of part two. I felt so confident, and I shouldn't have been. Okay, day 16. Okay, we've been over this, the reindeer maze. Reindeer maze. I mean, this had some fun intrigue. Uh, Part two did get me for a while until I realized I shouldn't be, I realized I was searching. No. Part two, I got pretty quickly, actually. It took me 24 hours because I decided to go to sleep, but it just took me a while to go move away from Dijkstra. I'll say this is a tier B because, I don't know. You go through a maze and there's like one little, you're allowed to clip through walls, but still feels like a classic AOC. Some days I just wasted time doing bounds checking, even though the entire area is closed within the walls. Yeah. I mean, I did that too, but it's not much of a, at least for me, it's not much of an issue because it's just like dot filter area dot contains. Although, I mean, for this day, I think bounds checking did end up being important for me. Uh, Bounds. Nope, I guess I didn't do bounds checking here. Yeah, it shouldn't be necessary. Right, because we just search for other pieces that are also on the same path. Oh, wait, hold on. I'm confusing 16 and 20 again. Okay, I just reviewed 20. 16 was an actual maze. Um, yeah, but I don't think I did any bounds checking because the walls helped you there. Let's say A. I don't know if it should actually be B. I feel like I should fill up C more. Yeah, 16 is the turning one. Um, and 17. Oh, 17 is easily for me another one of the S tiers. Reverse engineering. The turning radius on these reindeer. I know, right? Cause to turn. They must have come to a complete stop, basically. Yeah, like they have to reset everything. Maybe they're just going so fast. They have to like full stop, break. Any accessibility VM? Yeah, day 17. What did I do for this one? Um, oh yeah, I had a lot of fun implementing this CPU class. I mean, I think it slowed me down because I could just do it from the strings, but I like modeling it. And I'm happy with how the code turned out. Like, this feels to me like very debuggable and extensible. Um, and I liked, by the end, like I could write these tests very concisely. And then I mean, that's just part one. So part one, writing the VM was fun, but part two, doing the reverse engineering was super fun. You're still mad about the C register? Um, why do you say that? I don't really. Mm. Oh, because you could just directly compute. Right, you could just directly compute. This one was your favorite? I think it's close to my favorite as well. It was definitely, I think, at my favorite at that point. Um, 14 wasn't my favorite when it landed, and then I think this became my new favorite. Just because I don't know, reverse engineering is super fun, and you don't get posed with the reverse engineering problem very often, do you? Hey, thanks. I like wearing these too. They became really important to wear this season because I had to hide how bloodshot my eyes were from the lack of sleep. Um, yeah, not much more to say. This is a classic AOC problem. Day 18, it was good to get a break. What was this? It was so um yeah, you didn't even really need to Dijkstra. I started with a Dijkstra, but honestly, you could just flood fill. Um, yeah, and then path to the end. Um, and then just binary search for the same thing, flood fill. I do like writing binary search with range. I like highlighting this. It's a fun trick. Yeah, day 18 was an easy one. Day 19 was also an easy one. Like we got 2 days break. Um, I don't know. We put 18 here in tier C. I mean, like it's easy. It's good to get a break. It's less interesting. There's not much intrigue in here. What's the way to do it? Let's see. Day 19. Part 2, you recalculate the path once the old one got blocked. Once the old one got blocked. Oh, I see. You just kept the same path and checked if that path was still. Oh, okay, that's smart. Right, so you don't keep searching a path at each one. Okay, right. So that'd also get you some efficiencies, and it would completely just depend on like how randomly things get onto your block. Yeah, that makes sense. Probably still not as fast as a binary search, but still clever. Day 19. This is also super easy, but I brain farted. Right, this is my first code, basically. And I was like, well, let's do some optimizations. I can memo, I can do blah, blah, blah. And I decided to do blah, blah, blah. And how long was that detour? Like a couple hours, it felt like. But I still liked it. Let's say 19. I don't think it should be in C tier unless we're putting like 1, 2, 3, 4 in D tier. I guess something has to be in C tier. Like these were more interesting than the C problem than these two problems, right? Maybe day 19 feels less interesting because it comes later in the season. But if this came up as problem 4, you'd be like, oh, that's a fun one. I don't know. For the day 19 one, you arrived 20 minutes late and solved in like 5-10 minutes. I believe it. I believe it. Yeah. I mean, I feel like I should have got that in 10 minutes. For me, it'd be 10 to 15 minutes, but nonetheless. Wait, I missed a message. Part 2, you wasted some time trying to find the range where the output was 16 bytes long. But since the pattern repeats, it didn't really work out. Oh. Part 1, you solved the back and forth, the back and front simultaneously, because that's where you get definite answers. Are we talking about 19 or 18? You're talking about 18. No, 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 19. Oh, you know what? No, on 19, I started by doing like a split, like split into a tree and then search left and right. And then I was thinking, oh, to optimize this, I'm gonna have to make a tree, like a tri tree. Never was sure in the pronunciation. I was super overthinking 19. And then it occurred to me to just do the start. Yeah, the towels, that makes sense. Yeah, day 19 kind of highlighted a recognition issue for me. Day 20. Okay, we've already talked about this one plenty. So I'm gonna skip over that. And day 21. I think this gets an S tier. It's not like the same S tier as 14 and 17, but I don't know. It was a fun problem statement. And just fun to try and optimize. Oh, I was in the middle of trying to tighten up this code. But yeah, I definitely see how how people get super fast deltas by just doing a memo on their part one code, basically, which that's another case where it took me a little while to do a memo. I already had my part one, but I wanted to rewrite, and during my rewrite, I added a fake optimization that I still don't understand why it doesn't work. Like I need to understand. I still don't understand what makes paths shorter besides having besides having directions chunked. Um, yeah, so I thought for part two I could just go straight to in my rewrite I could just go straight to just chunking them and not worrying about searching multiple options for whichever is the minimum. But apparently it's more complex than that. So definitely a candidate for me to explore. Depends on them making the path in the next keypad shorter too. Yes, yes, I understand that. But I mean, and as I was drawing them, I could never find such a case where the keyboards got shorter, right? Where were we there? Yeah, because you'd always have the A's between them. And you'd either have like left down, up right, or down left, up right. So if those were your two options, you still end up having all the same directions, just in different orders, and then they're all separated by A's. So chunking didn't even really matter, right? Yeah. So I don't fully understand why there's something more than chunking that makes it shorter. But I tried to understand it, and that's where I spent a lot of my time that night. But definitely, I would call that one of our S tier puzzles. And the monkey part. Yeah. Do you remember the monkeys problem from 2022, where all the monkeys are doing this math stuff? I thought this was pretty fun to parse. Um, anyway, oh yeah, day 22 is another break. Um, there wasn't much to this. I think pretty much my first implementation worked right off the bat. And I feel like everyone was solving it pretty fast that night. We'll put that next to 18 and 19. Another break day. Um, did anyone have any interesting optimizations here? Like here, I didn't even try to optimize. I just grabbed all of them, dumped them all into a map. Didn't try to short circuit at all. And since it worked, I was happy to just submit with that. Day 23 was a bit more interesting though. A Fire, thank you for the follow. Right, the LAN party. Um, yeah, okay, my final code ended up being pretty short here. This feels so I still feel like my solution was a hack because I just knew that everything was connected to 13 other, and I just checked if 12 of those 13 were connected to each other. Um, and doing that check was pretty easy. So basically, I just checked if the second largest possible node, node cluster, existed. If it existed, that was it. Um, I got part one pretty quickly, but geez, so max clicks is an NP hard problem, right? So that's why I kind of just meandered so much while thinking about this one. Let me see. Max click. The click problem. Is it NP hard? It doesn't say. Approximate clips is almost NP complete. Click decision problem is NP complete. Okay. Um, that's something for me to read up on. Like my graph theory is behind. You started with a group of 3 like in part 1, and then you check each neighbor to see if the neighbor of all the other nodes 2. Okay, so just grow the group. Yeah, that's fair. And perhaps I should have gone with the same approach because they did tell us that this would be a criteria, right? If it has a T, it's going to be one of those. I wonder if my answer had the T, the one that starts with T in it. I don't think my answer even had. So, oh, you know what? It's a good thing I didn't do that, right? The historian's computer was supposed to start with a T because my answer didn't have a computer that started with a T. So I think that's a little bit nasty. I'll put this in A, I think. Because, I mean, we're used to doing a bunch of Dijkstra variations, but I don't think we get too many graph problems. Yeah, the T doesn't apply to part 2. All right, and day 24. Oh, okay. This, I would say this is S tier. It's so S tier, it might push 21 down into A tier. Um, I don't know. It was more reverse engineering. And we got 2 reverse engineering problems this year. So that's pretty fun. Oh, my metaprogramming solution. We all had fun with this, right? I still want to rewrite the syntax of the solution and use a state monad, but that's for another time. Part 1 was straightforward. I agree. Part 2 is tricky. I mean, so part 2 is like intriguing and interesting. But it wasn't like so tricky that we needed a lot of theory, right? Like there was always, so I felt like with me, there was always a way forward. Like I could always think of the next thing to try, next thing to do. So it's not like the kind of tricky that gets you stuck, but it's a kind of tricky that keeps you moving. A lot of checks and printfs for you. You want to clean it up? Yeah, I want to clean it up too. Look at all of this. That was a pretty ever set, almost 2 hours delta. Yeah, I think I think I might have had a 2 hour delta too. You're not done with part 2 yet? Well, it's a fun one. What's my delta for 20? Oh, I didn't have a 2 hour delta. I had a 4 hour delta. So I saw part 2 right at 4 hours. Yeah, part 1 was definitely straightforward. I feel like that's always the case with these reverse engineering problems. Same thing with 17, right? No? I guess I didn't find part 1 super straightforward on 17. First thing to figure stuff out was seeing that the count of different gate types matches the expectations of an adder circuit. with no no-op combination gates to confuse you. Oh yeah, that would have been nasty. And I'm glad they stuck to like one implementation. Like it is pretty standard. The only tricky thing they did was they like sometimes switched the order of the inputs. Like sometimes it'd be X and Y, sometimes it'd be Y and X, which was like mildly annoying but workable. I was sort of disappointed that my add bit approach, like simulating the whole machine, but just adding up one column to find the columns where there's an issue. I was disappointed that that didn't really run fast enough for me to just run it over all the columns. So either I need to optimize or I need to just understand more about how this machine is wired. And day 25. I've already forgotten what day 25 was. Oh yeah, okay, super straightforward. I'm gonna put this I'm gonna put this in B. I mean it's easy, but I mean I think it's a fun concept of like thinking about the keys and parsing them and whatnot. Um okay. You missed some of these problems, but I think we've got the start of a tier list. uh, let's let's see if you can plug some of these in more. So day 5 is a topless sort not needed. 1, 2, really easy. Um, 3, regex search. 4, what was 4? Uh, Xmas search. I think that goes up into C. 5. Oh, 5 was interesting. That was kind of fun. I could put that in B. And 6 with the guard moving around. Like these are fuzzy. Could take more thought. 7 was a straightforward recursion. Kind of disappointed 25 didn't have a part 2. Yeah, I felt that too. I mean, like the first time it happened. But I appreciate that it's a break. Because I don't know, often people are celebrating and might not have much time. So it's good not to spend a long night on 25. What was the bridge repair? Oh, the bridge repair was kind of cool. And we're just missing 8 and 9. Oh, 8 I really liked. 8 and 9 are actually already in there. Great. So we have a provisional ranking for all of these. If anything, maybe 21 moves down here to 8 here. All right, we did it. Yeah, field cheated day 25. I feel you there. All right, well, we did it. So who else is planning to go back through the past problems this year? Like that's definitely a solid goal of mine this year is to finish them all. I think I'd like to be part of the 500 club. Yeah, GG's everyone, and thanks for being around. This has been a fun community. AOC is really a fun community, and you've kept this stream fun, so I appreciate it. Um, I believe Snow is probably still finishing And that seems to be where all of the admin streams end up. So we'll probably go there. You'll try to solve past years, but that's a problem for 2025 Hellhound. Yeah, completely fair. Um, yeah, I mean, it's a big commitment. I mean, for me, I guess I only have like 5 years-ish to solve. I could do one every other month. And of course, like the first few days of every month, you could just do in one sitting. And I won't be doing them at midnight. I could just do this when I'm like awake and alert. My all-time favorite challenge. Oh, okay. Hold up. Um, so 2021, there were a few that were really interesting. And I think this part of this was like this all being new to me. 24 was a reverse engineering one. And this is my first time encountering that kind of a problem. So that's one of my favorites. I think 22, 19, 16. Let me think. Reactor reboot. So this is like 3D cubes that were overlapping. I thought that was super fun. The beacon scanner was notorious for being like another tricky 3D graph one. But I would say that was not the same kind of favorite as 22. 16, decoding this binary was fun to do. I wouldn't say it was I wouldn't say that's an all-time candidate, but definitely 22 and 24 of 2021 were good, good ones. Um, let's look at 22 and 23. 22. Oh, this was the one that had the elephants. uh, the elephants was like a Dijkstra search with like very complicated state. Um, 19 was an interesting like range search problem. I'm trying to think what was a problem. There were a few kind of parsing languagey problems. I think maybe 2021, there's one where you're like helping sea creatures solve their homework. And that was interesting. I don't think this is what I'm thinking of 2020. It's easy to point out to these two just because they stick out in my memory, and it was my first Avena code. So I would say 22 and 24. I don't know, 3D cubes overlapping, intersecting. That was fun. And since they're so large, like you really had to optimize them with ranges. And this 24, my first reverse engineering problem. But definitely had favorites from a few past years. This was fun. But, you know, I can't really say right away which is my all-time favorite. Each year had a few favorites. This year it had a few favorites. But yeah, we'll see. I'll be able to say more when I finish them all this year. Okay, let's call it a night. What was going on day 24, 2023? 2024, wait. Events 23, 24. What was that day? I can't remember. Oh, wait. I hated that one. Well, I didn't hate it. This was the Gaussian elimination one, right? So you just had to look for an intersection of any three lines to solve the problem. And it just took me so long to do that. I remember you were in the chat with me uh, till like 4 a.m. solving that. Yeah, that was the one. That was the one. Okay. Well, let's call it a night and see how everyone else is finishing up in Snowstream. And yeah. Oh, thank you for the follow. I appreciate it. And I promise I'll be back around later this year. Probably a 2-week break and maybe Wednesdays. We'll see.